In this presentation we are going to look at some very simple maths operations with the Julia programming language. So I'm going to set up a little value variable here, x is equal to 5. So far so good. And return that. You notice that the value gets returned, it gets printed straight to the screen. Anybody who's familiar with MATLAB or Octave might be familiar with that. What you could do there is to turn it off is use the colon there. So that is x is now 5. So let's look at some simple operations here. The square root of x, there we have it there, 2.3 to several decimal places. And we can also do the cube root, CBRT of x. And let's see the absolute value of x, if that was necessary, and maybe also the sign of x, just to see is it a positive number. If we wanted to go for a, if we actually specified it as minus x, we would have got a sign of -1 there, just to say it's a negative number. Let's have a quick look at sign of 0. So that's the sign of 0 is 0. 0 is not positive, nor is it negative. So that's just a few simple commands to start off with. I've just cleared the screen there. What we might also look at is some interesting maths functions. First off, let's just introduce pi. Pi is here. And let's also look at the type of functions that are available. So we have, how you might find that out is the type of. So pi is a maths constant. X, capital X, is an integer, and we could also have type of the square root of x. It's a float of float. So, and that is, that's some important stuff there. A very interesting function might be to do the hypotenuse function. This is something that people who do the Project Euler, actually, if you're not familiar with that, have a look at those. Project Euler, it's a website, maths puzzles. Anybody who is familiar with that might know that there's a couple of hypotenuse related puzzles. So if you all recall Pythagoras' theorem, the square of the hypotenuse is the sum of the square of the other two sides. We can use the function hypot to compute the hypotenuse of when we specify the other two sides. Here it is 5.0. So you can specify other ones there as well, and so on. So that is the hypotenuse function. Now, some very simple ones to go back to: exponential numbers, exponential of 7, okay, next exponential of x. So far so good. That's simply in common with all of the programming languages. The log, going in the opposite direction. So that's the natural log of x. The log of x, that's the log to the base e. And we can also specify other bases. But what is different about Julia is that you would actually specify the base first. So in other programming languages, if you wanted to find log of 100 to the base 10, you might write it like that. In Julia, you specify it the opposite way. You specify the base first. So log to the base 10 of 100. 2. Just what would happen there about if you'd done it the other way. There you go, you get 0.5, the square root. So if you wanted to use log to the base 2, log 2, you don't have to specify 2 as a separate function. So log to the base 2 of x. There we go there. And there's the sine of x as well, cos of x, and tan of x. Those are all supported by Julia as well. Alright, that's enough for now. Thank you.